So hello everyone. At this class I'm going to start a new chapter, that is probability. So you have some idea already, you got in class 10, you got in class 11, now again in class 12 also you have to study, but little bit extension means basics तो रहेगा probability का, उसके साथ थोड़ा सा applications भी study करना है probability का. Okay? So all of you know the meaning of probability, that is the degree of uncertainty. Yes? So first of all I want to discuss some basics, or you can say the definitions of probability. Okay? इसके बाद मैं धीरे धीरे एक एक करके सब टॉपिक में जाऊंगा. Okay? So let us recall the definitions again. First of all, you see the definition of experiment. What do you mean by an experiment? An operation which can produce some well-defined outcomes is known as an experiment. Yes? So what is experiment? An operation which can produce some well-defined outcomes is known as an experiment. Outcomes means result. Outcomes means the result. Okay. Now what is random experiment? If in each trial of an experiment conducted under identical conditions, identical means similar conditions, conducted under identical conditions, the outcome is not unique but may be any of the several possible outcomes, then such an experiment is known as a random experiment. So definition से ज़्यादा clear होगा जब example दूंगा. That's why I have given an example. So example of random experiment क्या हो सकता है? Tossing a fair coin, drawing a card, etc. Drawing a card, etc. इसमें coin का भी बात आएगा. Tossing a fair coin, drawing a card. ऐसा examples random experiment का examples है. Okay? Even you can consider die also. If you throw a die, so वो die का भी experiment जो है वो भी random experiment का example include हो सकता है. ठीक है? Next will come the definition of sample space. What do you mean by sample space? The set of all possible outcomes. Outcomes means the result. The set of all possible outcomes in a random experiment is called a sample space. So what do you mean by sample space? The set of all possible outcomes in a random experiment of a sample space in a random experiment is called a sample space. Okay? Now I will give one example of sample space, क्योंकि probability का एक important part है the sample space. If you don't know the meaning, or if you don't know how to write the sample space of a random experiment, any random experiment like tossing a fair coin, drawing a card, then throwing a die, if you don't know how to write the sample space of those random experiment, then it will be difficult to understand probability. Okay? So now I will give one example, one easy example of sample space. I will give two examples. Okay? So let us take the first example. First example is tossing a fair coin. So tossing a fair coin, इसका sample space लिखना है. तो कैसे लिखना है? See, sample space is denoted by S. Okay? Sample space is denoted by S. अभी sample space का definition और एक बार पढ़ना है. The set of all possible outcomes. Set बोल दिया. तो set chapter जो class 11 में study किया था, generally वो सब elements को एक कर्ली ब्रैकेट के अंदर लिखना है. फॉर एग्जाम्पल से vowels in English alphabet, if you write those vowels in English alphabet within a curly bracket, then it will form a set. Yes, एक कर्ली ब्रैकेट के अंदर जब एलिमेंट्स को एंटर करना है तब एक सेट फॉर्म होता है. सो हियर आल्सो we have to use the word set, the set of all possible outcomes of a random experiment. So random experiment यहाँ पे क्या लिया? Tossing a fair coin. So if you toss a fair coin, how many possible outcomes are there? First of all, you should know for the experiment which you are going to use, how many outcomes are possible. So if you toss a coin, how many outcomes are possible? Two outcomes, either head or tail. Probability means the degree of uncertainty. We don't know whether head will come or tail. So you have to consider both the face, head as well as tail. So when we represent or when we write those elements within the curly bracket, then it is called the sample space of the random experiment. Okay, you know the definition of random experiment. I have given the example of random experiment. Now the definition of sample space with example. So tossing a fair coin, इसका sample space कैसे लिखना है? Sample space is denoted by S. So S is equal to curly bracket H comma T, which is the sample space of this random experiment, tossing a fair coin. Okay, let us take one more example, throwing a die, throwing a fair die. So if you throw a die, then what will be the sample space of that random experiment? Again, sample space is denoted by S. So within the curly bracket, if you write how many possible outcomes are there, first of all you should know how many possible outcomes are there if you throw a die. 6 possible outcomes, 1, 2, 3, 4, 5, 6. So when we represent those elements, that is 1, 2, 3, 4, 5 and 6 within the curly bracket, so this will be the sample space of the random experiment throwing a fair die. Okay, so in this way you have to represent the sample space of a random experiment, the set of all possible outcomes of a random experiment. एक experiment में जितना आउटकम्स होगा, पॉसिबल आउटकम्स, वो सब आउटकम्स को अगर कर्ली ब्रैकेट के अंदर रिप्रेजेंट करोगे तो वो हो जाएगा सैंपल स्पेस. ओके, तो ये हो गया बेसिक डेफिनेशंस ऑफ एक्सपेरिमेंट, रैंडम एक्सपेरिमेंट एज वेल एज सैंपल स्पेस. सम मोर डेफिनेशंस आर देयर, आई विल गिव, बट बिफोर दैट वन इंपॉर्टेंट पार्ट जो जनरली स्टूडेंट प्रॉब्लम फेस करता है, जिसको कार्ड्स में ज्यादा आइडिया नहीं है प्लेइंग कार्ड्स के लिए, तो मैं एक टेबल दे दिया. ठीक है, जस्ट न्यूमेरिकल सॉल्व करने के लिए यूज होगा ये टेबल. ओके, सो प्लेइंग कार्ड्स टोटल रहता है 52. टोटल नंबर ऑफ प्लेइंग कार्ड्स होता है 52. कलर्स होता है 2, दैट इज रेड एंड ब्लैक. देयर आर 26 रेड कार्ड्स एंड 26 ब्लैक कार्ड्स. ओके, रेड में और 2 पार्ट रहता है. These four are called suites. Okay, diamond, club, spade, heart. So under the red, diamond 13, heart 13. Under black card, club 13, spade 13 होता है. ठीक है, ये जस्ट न्यूमेरिकल सॉल्व करने के लिए यूज होगा. 52 कार्ड को 2 कलर में डिवाइड किया गया है, 26 रेड 26 ब्लैक. फिर 26 रेड को और 2 कार्ड में डिवाइड किया गया, दैट इज डायमंड एंड हार्ट. 13 13 26 होता है. ब्लैक को भी सिमिलरली, ब्लैक को भी 2 पार्ट में डिवाइड किया गया, क्लब एंड स्पेड. 13 13 26. ठीक है, सम मोर डेफिनेशंस आई विल गिव नाउ. सो नेक्स्ट I will explain the definition of an event. So what do you mean by event? This definition also will come under the probability only. So what is event? A subset of a sample space associated with a random experiment is called an event. What is event? A subset of a sample space associated with a random experiment is called an event. Now what do you mean by subset? जो सेट में आता है. देखो, प्रोबेबिलिटी चैप्टर डिस्कस करो, लेकिन इसमें भी थोड़ा सा सेट का कॉन्सेप्ट चाहिए. ठीक है, नॉट ओनली सेट, कॉम्बिनेशन का भी कॉन्सेप्ट चाहिए प्रोबेबिलिटी में, राइट? ओके, सो what do you mean by subset? If you don't know the definition of subset, then how can we give an example of an event? Suppose if A and B are two sets, if A and B are two non-empty sets, then A is said to be the subset of B if every element in A must be present in B. Okay? A का एलिमेंट्स B में होना चाहिए, then only we can say that A is a subset of B. What is a subset? A and B are two non-empty sets, then A is said to be the subset of B if every element in A present in set B. This is the symbol of subset. Okay, this is the symbol of subset. So here also I am going to use the same symbol, but before that, once again I will explain the definition. A subset of a sample space associated with a random experiment. Say for example of an event, a coin is tossed, then sample space is h, t, yes or not? सैंपल स्पेस हो जाएगा h, t, जो अभी जो सैंपल स्पेस का एग्जांपल दिया था हमें. Let E be the event getting a head. So getting a head मतलब एक कॉइन को अगर एक बार टॉस करना है तो एक ही बार हेड गिरने का चांस है, बिकॉज एक कॉइन में दो ही फेस होता है, आइदर हेड और टेल होता है. तो कॉइन जब टॉस करना है तो आउटकम आइदर हेड होगा और टेल होगा. So since E denotes getting a head, so there is only one way we can get a head if you toss a coin, because in a coin there are two faces, one face head, another face tail. Okay, so if a coin is tossed, the sample space is h, t. Let E be the event getting a head. तो ये भी कर्ली ब्रैकेट के अंदर ही लिखना पड़ेगा. Why? Because a subset of a sample space associated with a random experiment is called an event. Subset again मतलब E भी यहाँ पे सेट रिप्रेजेंट कर रहा है, और सेट का मतलब कर्ली ब्रैकेट के अंदर ही एलिमेंट को बैठाना है. ओके, नाउ यू कैन चेक द एलिमेंट व्हिच इज प्रेजेंट इन E is there in this set S or not? Here S and E both are set, yes or not? Here S and E both are sets. Now I am telling that whether the element present in E belongs to this set S or not. Yes, so therefore we can say that here E is the subset of S. मतलब A subset B का definition क्या है? जब A का एलिमेंट B में होगा. तो यहाँ पे भी E का जो एलिमेंट है वो सैंपल स्पेस S में है ना, so that means we can say that E is the subset of S. so ये एग्जांपल वेरीफाइड हुआ कि नहीं ये डेफिनेशन में? A subset of a sample space, E is the subset of this sample space S. A subset of a sample space associated with a random experiment is called an event. So since here E is the subset of the sample space S, so that means we can say that E is a subset of S. So this is an example of an event. ठीक है, एक सैंपल स्पेस होगा, उसका जो जो एलिमेंट्स है उसमें से एटलीस्ट एक एलिमेंट वो इवेंट में होना चाहिए. यहाँ पे भी एक एलिमेंट है इवेंट में, जो एलिमेंट सैंपल स्पेस में भी प्रेजेंट है होना चाहिए प्रेजेंट. देन ओनली वी कैन यूज दिस सिंबल. दिस इज सबसेट सिंबल. ओके, सो दिस इज द डेफिनेशन ऑफ इवेंट. नेक्स्ट विल कम टाइप्स ऑफ इवेंट. टाइप्स ऑफ इवेंट. नंबर 1, impossible and sure event. Impossible and sure event. Now what is impossible event? Impossible event means the empty set phi. Empty set is denoted by phi. सब कुछ definition sets में मिला था set chapter में, right? The empty set phi, or you can say which is not possible. Yes, impossible event means which is not possible. That is called an impossible event. Okay, sure event. अच्छा, can you give an example of impossible event? Suppose a die is thrown, तो इसका sample space क्या होगा? 1 2 3 4 5 6. Let E be the event getting a number greater than 6. Is it possible? Because एक die में तो 6 तक ही होता है नंबर, so a number greater than 6 तो possible ही नहीं है. So that means it is an example of an impossible event which is not possible. Okay, sure event means which is possible. The whole sample space is called sure event. Okay, impossible event का definition क्या है? Which is not possible, or you can say the empty set phi is called an impossible event. Sure event means द होल सैंपल स्पेस इज कॉल्ड श्योर इवेंट. मतलब वो श्योर है, मतलब वो एक्सपेरिमेंट, वो कॉइन टॉस करने से आइदर हेड और टेल आएगा ही, तो मतलब वो सैंपल स्पेस में एच टी दोनों को इंक्लूड करना है. सो एच टी अगर दोनों को इंक्लूड करना है मतलब ये पूरा सैंपल स्पेस ही तो आ गया ना. सो द होल सैंपल स्पेस इज कॉल्ड श्योर इवेंट. ओके, नाउ सिंपल इवेंट. व्हाट डू यू मीन बाय simple event? If an event, I'm giving the definition. Listen the definition carefully. If an event has only one sample point, if an event has only one sample point, अभी तुम लोग पूछ सकते हो कि what is sample point? Sample point are nothing but the elements. सैंपल स्पेस के अंदर, कर्ली ब्रैकेट के अंदर जो जो एलिमेंट एंटर किया, दीज आर कॉल्ड सैंपल पॉइंट. इन दिस सैंपल स्पेस हाउ मेनी सैंपल पॉइंट्स आर देयर? 2, हेड and tail. So these are called sample points. Okay, now what is the definition of simple event? If an event has exactly one sample point of a random experiment, is called a simple event. Okay, can you give one example of simple event? Yes, this example will satisfy the definition of simple event, because here the event E contains exactly one sample point. Yes or not? So this example will satisfy the definition of simple event also, जिसमें एक ही एलिमेंट होगा. Next one is compound event. It is exactly opposite to simple event. Compound event means if an event has more than one sample points. Okay, if an event has more than one sample points, that is called compound event. So can you give one example of compound event? Let us take one example. Suppose a die is thrown, तो इसका sample space क्या होगा? 1, 2, 3, 4, 5, 6. Yes. Let E be the event. Let E be the event getting even numbers. Let E be the event of getting even numbers. So in this sample, you have to find all the elements from the sample space only. Okay. So how many even numbers are there in this sample space? 3 even numbers. What are those 3 even numbers? 2, 4 and 6. Now can you tell me how many sample points are there in this event? 1, 2, 3. 3 sample points are there. So what is the definition of compound event? An event which has more than one sample point. So this is the event which has more than one sample point. So this is an example of compound event. Okay. Next will come equally likely event. मैं event नहीं लिखा, equally likely event. Since these are the types of events, so of course यहाँ पे equally likely event ही होगा. So equally likely का मतलब क्या? ये सब कुछ definitions class 11 में मिल गया था, और एक बार मैं repeat कर रहा हूँ. Okay, equally likely event means the given events are said to be equally likely. The given events are said to be equally likely if none of them is expected to occur in preference to the other. Equally likely means the given events are said to be equally likely if none of them is expected to occur in preference to the other. Say for example, in throwing an unbiased die, all 6 faces are equally likely to come. Okay? In throwing an unbiased dice, all 6 faces are equally likely to come. This is an example of an equally likely event. इसका मतलब क्या है? जब एक the given events means events are the subset of a sample space. Okay, the given events are said to be equally likely. Events means are the subset of a sample space. The given events are said to be equally likely if none of them is expected to occur in preference to the other. तो मतलब जब एक डाई को थ्रो करना है तो टोटल आउटकम्स 6 होगा, 1 2 3 4 5 6. So we are not expecting that all 6 will come equally likely. लेकिन equally likely का मीनिंग क्या है? None of them is expected to occur in preference to the other. None of them. उसमें से एक भी नहीं. Total 6 outcomes are there if you throw a die. If none of them is expected to occur in preference to the other, it's called equally likely event. Okay? Next will come mutually exclusive event. Mutually exclusive का मतलब क्या है? Suppose there are two events, for example, there are two से ज्यादा भी हो सकता है. मैं पहले दो event का definitions बता रहा हूँ. Mutually exclusive means suppose there are two events A and B. Events A and B. So these two events are said to be mutually exclusive if A intersection B is equal to phi. The two events A and B are said to be mutually exclusive if A intersection B is equal to phi. Intersection means there is no common element between these two events. Phi means empty. Intersection means common. Intersection means common element जो सेट में यूज किया गया था. यूनियन, इंटरसेक्शन. इंटरसेक्शन सिंबल का मतलब है common element. So but here A intersection B equal to phi means what? There is no common element. Okay? So you can take more than two events. I have given here two events. You can take more than two events also. Okay? So the definition of mutually exclusive means the two events A and B are said to be mutually exclusive if A intersection B is equal to phi. Exhaustive event. Next will come exhaustive event. A set of events, listen the definition, a set of events are said to be exhaustive. A set of events are said to be exhaustive if one of them necessarily occurs whenever the experiment is performed. Okay? Exhaustive event means a set of events. I will give an example. Listen first. A set of events are said to be exhaustive if one of them necessarily occurs whenever the experiment is performed. For example, say E1, E2 up to En are the events of a sample space. Okay? Then E1 union E2 union En, this is equal to S, sample space S. This is the meaning of exhaustive event. Okay? मतलब सब इवेंट्स का अगर यूनियन ले लेना है तो उसके बाद अल्टीमेटली जाके वो सैंपल स्पेस ही आएगा. यू कैन टेक वन एग्जांपल. सपोज अ डाई इज थ्रोन, सैंपल स्पेस इज 1 2 3 4 5 6. Okay, let E1 be the event of getting even numbers. So these are the even numbers. Similarly, say E2 be the event of getting all odd numbers. So 1 3 and 5. Yes. So if I use union symbol, that means if you do E1 union E2, so this will be what? 1 2 3 4 5 6 or not? So this is equal to sample space S or not? Okay, so this is an example of exhaustive event. मतलब सब events का अगर union ले लेना है तो union means what? Which is present either in E1 or in E2 or in both. सब में होना चाहिए union का मतलब. और intersection का मतलब है only the common elements. Okay, so this is an example of exhaustive event. सब events का अगर union ले लेने से अगर sample space मिला तो वो होगा exhaustive events. Okay, so these are the basic definitions of the probability, not probability, related to probability. Okay, some more I will explain now. So next will come the probability of an event. So what do you mean by probability of an event? If there are n elementary events, if there are n numbers of elementary events associated with a random experiment, already I explained this word, that is random experiment. and m of them are favorable. If there are n numbers of elementary events associated with a random experiment and m of them are favorable to an event A, to an event capital letter A, then the probability of happening of A is denoted by P of A. P for probability. P of A means probability of the event A and is defined as P of A is equal to m by n. That means favorable cases by total number of case. और total number of case का मतलब है the sample space only. Okay. So for example, if a coin is tossed twice, then the sample space of the experiment will be HH, HT, TH and TT. Let T be the event, or you can say A be the event of getting exactly 2 hits. So in this sample space, how many such sample points are there getting 2 hits? There is only one sample point getting 2 hits, HH. Yes. So A is equal to curly bracket H comma HH. Yes. So what is the probability of getting exactly 2 hits if a coin is tossed twice? This is equal to, what is the definition? M by n. M means total number of favorable case. So favorable case का मतलब है यहाँ पे this is the favorable case here. So getting exactly 2 hits. So how many such points are there? One only. 1 by 4. 1, 2, 3, 4. In the sample space there are 4 sample points, whereas in the event there is only 1 sample point. So that's why probability of this event is 1 by 4. Okay. So this is an example of probability of an event. Favorable case by total number of case. So total number of case मतलब sample space से मिल जाएगा. There are 4 sample points. That's why denominator में 4 आ गया. Numerator में 1 क्यों? Because in that event there is only 1 sample point. Right? So this is all about the definition of probability of an event. Now there are some important results on probability. Number 1, probability of an event. P of A means what? Probability of an event A. 0 less than equal to P of A, which is less than or is equal to 1. Okay? 0 less than equal to P of A less than equal to 1. Next, probability of an impossible event is always 0. What is the definition of an impossible event? Which is not possible. So that's why the probability of the impossible event is always 0. Okay? Which is not possible. अगर possible नहीं है तो उसका probability कैसे ढूंढना है? Which is always 0. Number 3, probability of a possible event. Possible event, or you can say sure event. Probability of a possible event or sure event is exactly 1. Next, probability of A union A complement. What is this A? A is say any event. So A union A complement is equal to P of S. Okay? Probability of A union A complement is equal to P of S. P of S means probability of the sample space S. Okay? Here I'll give you an example. Say a die is thrown, then the sample space is 1, 2, 3, 4, 5, 6. Yes. Let A be the event getting all even numbers, that is 2, 4 and 6. Then what about A complement? A complement is nothing but here, in case of probability, we can find A complement by using the result S minus A. Whereas in set, we used to write universal set minus A, right? So here, that universal set will be replaced by the sample space S. बात same है, वहाँ पे universal set के जगह में यहाँ पे sample space use करना है. So A complement is equal to S minus A. So S minus A means, S means 1, 2, 3, 4, 5, 6 minus 2, 4, 6. तो क्या रहेगा? 1, 3, 5. Yes or not? So if you take union of these two sets, A union A complement, 1, 2, 3, 4, 5, 6 सब कुछ ही तो आ जाएगा. So this is nothing but P of S only ना, because sample space में तो 1, 2, 3, 4, 5, 6 है. Okay? So A union A complement, probability of A union A complement is equal to P of S. But probability of A intersection A complement is equal to probability of phi. Why? Because intersection means all the common elements. Is there any common elements between these two sets? In set A, there are 3 elements, 2, 4 and 6. Whereas in set A complement, there are also 3 elements, but 1, 3, 5 are there. Is there any common element? No common element. So that's why probability of A intersection A complement is equal to probability of phi. Probability of A complement whole complement, this is equal to P of A. ये तो पता ही है. It is this result already you got in class 11. Probability of A complement whole complement is equal to P of A. The next one is, मैं बोला था पहले ही प्रोबेबिलिटी में सेट्स का कॉन्सेप्ट चाहिए, थोड़ा सा कॉम्बिनेशन का कॉन्सेप्ट भी चाहिए. लुक एट द नंबर 7. Sometimes we have to select R objects from n distinct things. Sometimes we have to select R objects from n distinct things. Then we use the formula NCR, where n means number of objects, R means from those distinct objects how many we have to select. So NCR is equal to, we all know the expansion formula is n factorial by n minus r factorial into r factorial, where 0 less than equal to r less than equal to n. You have to be careful when we use this formula. R must be less than or equal to n. R कभी भी n से बड़ा नहीं हो सकता है, इक्वल हो सकता है, छोटा हो सकता है n से, लेकिन R कभी भी n से बड़ा नहीं होगा. Okay, so these are some important results. Some more formulas are there. I will give all these formulas. Okay. So now the main part of class 12 probability का जो अभी तक जो डिस्कस किया वो सब बेसिक डेफिनेशंस था related to probability, right? Now this is the main part. यहाँ से शुरू होगा class 12 का main part. Okay, so first of all you should know what is the meaning of conditional probability. Conditional probability, यहाँ से class 12 का part शुरू होता है. So conditional probability is what? If A and B are two events, if A and B are two events associated with the same sample space of a random experiment, A and B are two events associated with the same sample space, एक ही sample space का events होगा of a random experiment, then the conditional probability of the event A given that B has already occurred. यहाँ पे थोड़ा सा समझना है ये लास्ट लाइन. If A and B are two events associated with the same sample space of a random experiment, then the conditional probability of the event A given that B has already occurred. इसका मतलब है कि A और B इवेंट में जब B पहले काम कर लेगा, B का काम के ऊपर डिपेंड करके A काम करेगा, then the conditional probability is denoted by P of A slash B. Slash का मतलब conditional probability B. Okay, then P of A slash B, which is given by P of A slash B is equal to, this is the formula, expansion formula is P of A intersection B by P of B, where P of B is not equal to 0. Of course, if denominator will be 0, then it will be undefined, right? So that's why denominator 0 नहीं हो सकता है. ठीक है, क्या बोला था मैं लास्ट लाइन? जब A और B इवेंट के बीच में B पहले काम कर लेगा और B को देख के A काम शुरू करेगा, then it is denoted by P of A slash B. जो पहले काम करेगा वो मतलब स्लैश के बाद आएगा. जो इवेंट पहले काम करेगा वो स्लैश के बाद आएगा, जो इवेंट बाद में काम करेगा वो स्लैश के आगे रहेगा. सो P of A slash B is equal to P of A intersection B by P of B, where P of B is not equal to 0. ओके, हमेशा P of A slash B ही ढूंढना है ऐसा कोई बात नहीं है. सिमिलरली probability of occurrence of event B when A has already occurred, इसलिए बोला था हमेशा P of A slash B नहीं, P of B slash A भी ढूंढना पड़ सकता है. So in such case probability of occurrence of event B when A has already occurred. Now in this case, first A will do the work followed by B. So that means यहाँ पे यूज होगा P of B slash A, मतलब जो पहले काम करेगा वो स्लैश के बाद आएगा. तो यहाँ पे A पहले काम किया इसलिए A स्लैश के बाद आया. जो A को देख के काम किया वो स्लैश के आगे रहेगा, that is B. So P of B slash A which is given by P of A intersection B by P of A. फॉर्मूला बहुत आसान है. P of A intersection B सब दोनों में यूज हुआ, लेकिन डिनोमिनेटर चेंज हुआ. कब कब चेंज होगा? जब स्लैश के बाद जो रहेगा वही डिनोमिनेटर में आएगा. स्लैश के बाद जो रहेगा वही डिनोमिनेटर में आएगा. Where P of A is not equal to 0. Okay, so this is the definition of conditional probability. क्या है definition? If A and B are two events associated with the same sample space of a random experiment, then the conditional probability of the event A given that B has already occurred, that means B पहले काम करने से B को देख के जब A काम करेगा, then it is denoted by P of A slash B. जब A पहले काम करेगा और A को देख के B काम शुरू करेगा, which is denoted by P of B slash A, and this is the expansion formula. Okay, so there are some properties of conditional probability. Property number 1, say A and B are two events associated with the same sample space S of a random experiment. Then probability of S for sample space slash A means any event. So probability of S slash A which is equal to probability of A slash A which is equal to always 1. ये वैल्यू याद रखना है. Okay, probability of sample space slash any event which is equal to probability of A slash A. A slash A means event only. This is equal to always 1. The second one is probability of A union B slash C. This is equal to P of A slash C. And what is the formula of A slash B? This is the formula. This formula you have to use for this term. Similarly, plus probability of B slash C minus probability of A intersection B slash C. Do you know from where this formula has been derived? This formula has been derived from this one. Already you got in class 11. Probability of A union B which is equal to P of A plus P of B minus P of A intersection B. The second formula has been derived from this one only. P of A union B is equal to P of A plus P of B minus P of A intersection B. Okay. So probability of A union B slash C is equal to P of A slash C plus P of B slash C minus P of A intersection B slash C. इसके बाद जो नेक्स्ट स्टेप होगा वो नेक्स्ट स्टेप में क्या यूज करना है? P of A slash C का फॉर्मूला, this one. P of B slash C, same formula you have to use. And for this some value will be given in the question. Okay. Then number 3, probability of A complement slash B, where A and B are two events associated with the same sample space. Okay. Probability of A complement slash B which is equal to 1 minus probability of A slash B. Okay. Probability of A complement slash B is equal to 1 minus P of A slash B. There is one important point. If A and B are mutually exclusive events, then probability of A probability of A slash B is equal to 0. Okay. If A and B are two mutually exclusive events, then P of A slash B is equal to 0. Why? Already I have given the definition of mutually exclusive event. What is the condition of mutually exclusive event? A intersection B is equal to phi. Now if A intersection B is equal to phi, that means we can say that the probability of A intersection B is always 0. Yes or not? Phi means empty. So इसका probability तो 0 ही होगा. So what is the formula of P of A slash B? Here I have given probability of A slash B is equal to, we know, P of A intersection B by P of B. Yes or not? But if A and B are mutually exclusive, so P of A intersection B is 0. So if numerator is 0, that means the whole term will be 0. Yes or not? So that's why if A and B are two mutually exclusive events, then probability of A slash B is always 0. So these are some properties of conditional probability. So this is the main part, that is the starting part of class 12, that is probability ka. Okay? So in the next class I will discuss some numericals related to conditional probability. Okay? First of all, you have to go through all the definitions related to probability and then conditional probability as well as the properties of conditional probability. Next class I will discuss some numericals. Okay? So thank you for today.